Good morning, everybody. In the last video class of electromagnetic theory, I have given you a basic idea about T-coordinate system. And in order to understand the physics as well as in order to understand the electrodynamics book, David Griffiths book, which is very essential for any exam purpose related to physics, you have to understand three parameters that I am going to discuss here. So these three parameters are one divergent, two gradient, one divergent, two gradient, and three curl. Okay. So understanding of these three basic parameters in T-coordinate system is very essential. Why it is essential? And in order to solve the problem of Gauss divergence application, understanding of electromagnetic wave, and all other electromagnetic phenomena, you have to understand this divergent, gradient, and curl. What is the physical meaning of these three parameters? So first of all, I will try to the gradient. Suppose del F is a vector. Okay. Then how can you represent df? Physical meaning. So df means what? df by dx I k, df by dy j k, df by dz a k. Okay, and this is simple definition of gradient in a rectangular coordinate system. Okay, what is the physical meaning of this equation? Gradient means it is a difference. This is a function. It represents a function. F is a function, mathematical function. F is a function x, y, z. Okay, this represents change of function with respect to x. Okay, suppose you consider this is x, this is y, this is z. Suppose you consider point particle. This is suppose function x, y, z. Okay, this is a function. Suppose this is a person, particular person or particular particle. Suppose this is a particle in coordinate system and represented by this functional point or coordinate point. You can say that this is a three-dimensional coordinate. If this particular point moves from here to there, suppose particular location to another location, what will be the change with respect to x, y, z? It will be defined by this. So, what is the physical meaning? This will represent the change of a function with respect to x, change of function with respect to y, change of function with respect to z. Suppose this is an electric field vector in this three-dimensional space. Then what will be the change of electric field with respect to x, with respect to y, with respect to z? This is the physical meaning measured by the gradient. What's it? Okay, and gradient is a vector. Okay, gradient is vector. Now, what is the physical meaning divergent? What is the divergent? Divergent of f. Divergent of f means outward or inward flux. It measures inward flux or outward flux. This is known as the divergence. For example, we normally use the term diverge, mind diverge. So diverge means we are doing some work, but mind is moving some another direction. So we normally use in day-to-day life. But divergence means outward flux, inward flux. Normally you find this equation. Divergence of E equal to rho by epsilon. This is Maxwell equations. First, Gauss law, or you can say this is a Maxwell equation. So meaning of this equation is outward flux. Okay, the source is positive. This divergence measure outward flux, maybe inward, maybe outward. Suppose you consider positive charge particle, then we often represent the diagram like this. Why? Because it is often represented like this. So this is a positive divergence. So source is positive. This is why this divergence means divergence. If E is a function, here I am writing as a function. So divergence of E means it measures the outward flux. Divergent, when it is positive, it means outward flux. Source is positive. When if I write negative term, then it will be negative charge particle. So flux will be inward. Flux will be inward direction. Inward direction. Okay. So this is the meaning of divergent. Divergent, you may try to understand. Divergent means outward flux or inward flux. Okay. But in case of divergent of E is equal to 0, that means there is no divergent. No outward flux, no inward flux. Source, there is no source. But it does not mean that electric field is 0, because this is one-dimensional dE by dx equal to 0. So E equal to D equal to 0, E is equal to constant. Okay, constant may be 0, may not be 0, we don't know. So divergence of E is 0 means electric field may not be 0, but source is not there. Why not there? Because suppose we consider Gaussian surface, we are assuming that charge enclosed by this Gaussian surface, but we are getting electric field 0. Charge is not, if there is no charge, electric field is non-zero, because this electric field arises due to some other source, not inside the Gaussian surface. Okay, divergence is 0 means there is no flux. It does not mean that electric field is 0. Source is not there. Okay, this is the meaning of divergence. What is the meaning of curl? What is the meaning of curl? Meaning of curl means rotation. Suppose this is a phone. Suppose you are moving like this. You are moving like this. Okay, this movement is represented by function f. Then curl of f is not equal to 0. Curl means rotation. Okay, if suppose function is rotating, then it is non-zero. Okay, for example, I am giving one example. We often in static electrostatic del E equal to 0. Okay, that means electric field is non-rotation in static electric field, not dynamic electric field. So what actually we learn in static electric field, if you see the David Griffiths book, you will find like this. You will find this type of diagram. What does it mean? This is a lines of force. Lines of force always start from positive and then negative, but never come back from negative to positive. That means what? There is no circulation. Okay, you can understand this way also. Curl of E, curl means rotation of any function. But I am here writing curl of E. We often see this equation in static electricity. Curl of E is 0. That means electric field is non-rotating. Non-rotating means lines of force always start from positive, end at negative, but never come back from negative to positive. That's why it is not. It is 0. But whenever we encounter magnetostatic, you have seen this equation B equal to mu J. This equation Ampere's law. You have seen this equation. Why it is not 0? Magnetic field. This is a rotation of magnetic field. Why it is not 0? Because if we consider a current carrying conducting wire, okay, consider a conductor carrying a current I, magnetic field will be circular. Magnetic field will be circular. Okay, and having center on this circle, having center on the axis of the conductor. We have already understood. That is why curl of B is non-zero. Okay, this means magnetic field is rotating and it is non-zero. That means magnetic field is a rotational field and electric field is non-rotational field. Okay. But here in this case, B is 0. Here in this case, divergence is 0. Why? Because it is rotating. There is no question of outward flux, inward flux. That is why here 0. Divergence means outward flux, but here divergence is not 0. Okay. And another important thing I want to mention here is that divergence of B always with a magnetic monopole does not exist. But if it is like that, B is equal to rho by epsilon. It is non-zero. That means what? Electric monopole exists. For example, electron proton. Okay. This is the physical meaning of this curl and divergence. Now, how do you represent the wave function? This T representation in T coordinate system. We have a T coordinate system, rectangular coordinate system, spherical coordinate system, and cylindrical coordinate system. How can you represent this in three coordinate system? So I will give you one general formula. The representation already given in the David Griffith book in the starting page, chapter 1, around page number 39 or 40. But how they derive, they have not given. So, okay, I am giving you the general formula so that you can easily understand. No need to memorize, no need to remember. Just remember the simple general equation which is applicable for three coordinate system. Okay? See, first of all, I want to give you divergence. Divergence of f. F is any vector function. Okay? It's an arbitrary any vector function. So, this is general formula. This 1 by a is 1. Divergence. First I will give the divergence. Okay, this is general formula. 1 by a is 1, del f1, del x1. a1, 1 by a is 2, del f2, dx2, dx2, a2, plus 1 by a is t, del ft, del xt, at. This is the general formula applicable for T coordinate system. Now you may ask, so what is H1, H2, Ht? H1, H2, Ht is the curvilinear parameter which may be constant, may be variable. Okay, remember. And x1, x2, xt is a coordinate. Suppose in case of rectangular coordinate, it will be x, y, z. In case of spherical coordinate, r theta phi. In case of cylindrical, r phi z. And a1, a2, at is a unit vector. In cylindrical system, we often use as a I cap, j cap, k cap. But here I am not going to use I, j, k. Instead of I, j, k, in the last class I have already discussed, I will use ax, ay, az because of conflict. Okay. And f1, f2, ft is what? Normally we write as a vector. Is written as like this, na? fx, I cap, fy, j, k, fz, okay, this fx means this one means f1, okay, this one means f2, this one means ft. But you can if you confuse, you can simply write f also, no problem, because this first term is going to take the derivative of with respect to x. So if you add any numbers of parameter, it does not affect the differentiation result. Okay. Now, how can you remember? You see, now I am going to in a rectangular system. Rectangular system. How can you represent? It is very easy. In rectangular system, a1 equal to ax. Normally it is written as a I cap. Okay. a2 equal to ay. Normally it is written as j cap. So I am not going to read. at equal to az. Okay. And h1 equal to 1, h2 equal to h1 equal to h2, ht equal to 1. In rectangular system, I am talking about rectangular. Okay. x, x1, x2, xt, this is going to x, y, z, respective variable, t variable. Now this, if I reduce this equation, I will get this equation. This is the gradient, okay. df1 by dx ax, df2 dy ay, dft dz az. Okay, it is easy. You can remember this already. I have given df1 by dx I cap, df2 by dy y cap, z cap. This is very easy in the rectangular coordinate system. Okay. Now, spherical coordinate system. Spherical, you see, two spherical. This is spherical system. Spherical system. What will be the coordinates? Spherical system, you see, a1, a2, at becomes what? ar, a theta, a phi. These are a unit vector. Remember, this means you can, if you confuse r cap, theta cap, phi cap. This is one. Similarly, x1, x2, x3 becomes r theta phi. Okay, H1 equal to 1, H2 equal to R, H3 equal to R sin theta. Remember this. Only remember, you have to remember this term only. It is important. Rest of the term is easy. You can easily understand. So what is the general formula in spherical system? Del F. Now you can replace this is Fr, F theta, Fr. Okay. Df equal to 1 by 1. So no need to write first term. Dfr component. This is component of F along radial direction. Okay. Dr Er. Okay. Next term will be 1 by R. Df theta, d theta, a theta. Next one will be 1 by R sin theta, df phi, d phi, a phi. Okay, this is a representation in spherical system. So cylindrical system, how can you represent? Is very easy. Only remember that this term only. Rest of the term is only unit vector and the coordinate system. Okay. Cylindrical system, cylindrical system of this coordinate r, phi, z. These are the coordinates. So unit vector will be ar, a phi, a z. Okay. And here h1 equal to 1, h2 equal to r, h3 equal to 1. This is very simple. So gradient del f will be dfr, dr, ar, df phi, d phi, a phi, 1 by r is there, and dfz by dz. This is it. What you find that is very easy. Only remember this general form. And H1 is this one, cylindrical, and in spherical R sin theta. These two terms you have to remember. Now, why it is so important, I will tell you later. It is very, very essential to solve numerical problem, often asked in an exam. Remember, whatever in exam, normally question, application of Gauss law, mainly first part of electrodynamics, often comes either cylindrical or spherical system. But never expect any question from rectangular system. So you have to understand this is for gradient and that divergence. How can you divergence? What is the general formula of divergence? So it is very easy. I am giving you tips H1, H2, H3. So remember, divergence is a scalar quantity. Dot product. This is vector. And this is vector. Dot product of two vector always give a scalar. So first term, you remember, whenever consider dx1, okay, there must not be h2 and h3, no h1, okay. This is f1. Is it okay? h1 is missing here. Next, whenever I write f2, this h1 and h3 is there. F2 must be there, so H1, H2 is missing. Simple. This is what dH1, H2, F3, dx3. And this is simple general equation. Okay. So in rectangular system it will be easy. All H1, H3, H2 equal to 1. I am not going to show the rectangular system. Okay. But I am going to show the spherical and cylindrical system. One is spherical system. This r theta phi, your representation I have shown you. H equal to 1, H2 equal to r, H3 equal to r sin theta. So what is the representation? Del f. This will be what? R square sin theta. R square sin theta. First term, this will be d h2 h3 r square sin theta. So this will be dr first term. So it will be r square sin theta. F1 I replace r cap, r component. R component means F1 component. Next two will be d theta, d1 and 3, 1 and 3 equal to r sin theta, f theta. Next one will be d1 2, 1 2 means r, f phi, d phi. This is very easy. So it will be, so this is with respect to r, this are term theta, sin theta will come out, so it will be cancelled out, 1 by r square, d r square f r square will not come out, okay. Next term, r is constant, so r cancel out, 1 by r sin theta, d sin theta f theta, d theta, and d, sorry, 1 by r sin theta, d f phi by, this is representation. So problem is that you cannot remember this formula, but you can remember this formula. If you remember this formula, you can evaluate for rectangular system, cylindrical system, and spherical system. Any problem you can find out. So this is in spherical system. I am just showing how to remember cylindrical system. Cylindrical system. I hope you can easily evaluate r phi z. So it will be h1 equal to 1, h2 equal to r, h3 equal to 1. So you put this value, you will get, it will give what? It is very easy. Del f 1 by r, d by dr, 2 and 3, r f r is it. Next 1 and 2 r, phi r will be cancelled out, d f phi plus 1 to r, so this will be d z, r will be come out, d z. Is it okay? It's very easy formula to remember. Now why it is so essential? See in the last question. Now why it is so essential? The one question is given in question number 1. Why it is essential? In application, if electric field is equal to k r cube r cap in rectangular system, in a sphere, find the total charge density. This question comes in an exam. How can you find out? See, hints दिया है divergence of E equal to rho by epsilon. First we have to calculate rho we have to calculate. So often student often do like this, del E dot E equal to rho by epsilon naught, dE by dr equal to rho by epsilon naught. Then after that they take the derivative. This is a wrong procedure. So what you have to do? This is in spherical system. Once question is given in this question comes in the next exam. Once the question is given is like that. So then you have to remember this is a spherical coordinate system and this equation is divergent. So we have to use the divergent formula. But one thing remember that this, how can you know that this is spherical system? Either they will mention it sphere is mentioned, so we have to know this is spherical system. If they do not mention spherical system, they will give some hints that whether this problem is spherical problem or cylindrical problem. They will somewhat they will give a hint. So electric field vector means E equal to k r cube r cap. There must be 3 components. So 0 theta cap plus 0 phi cap. That means this 2 component is missing. So what is the, remember I have given the general formula del f equal to 1 by h1 h2 h3. So first term is related to r. Okay, first term you remember H2 H3 F1. Okay, here it is. If it is E, then it will be E1. Okay, then X1. Next term I am not going to write next term because it is wasting of my time. Why? Because this two term is missing. So this coefficient is 0, F2, F3 is 0. So no need to evaluate, is copied here. Okay, and you know the H1 equal to 1 in spherical 1, H2 equal to R, H3 equal to R sin theta. Okay, put this value. Put this value. Divergence of F equal to 1 by R square sin theta. This D, how much? R square 2 and 3, H2 H3, it will be R square sin theta F R dr. Okay, rest of the term is missing because here only first component is given, second theta component, phi component not given. That's why I am not writing third and second component. According to you can choose which term you have to edit. So it will be theta will cancel out. It will be 1 by R square d R square F R dr. Now it is this equation we have to use. So if this electric field C, divergence of E, if I write E, then I have to write 1 by R square d R square ER dr. Okay. Then divergence of E is equal to, divergence of E equal to, just put the value ER here, that is, but do not write that unit vector coefficient. This is unit vector. Unit vector coefficient you have to write here only. Okay, no need to write the unit vector. Okay, so it will be 1 by R square d by dr. It will already R square is there. It will be k R to the power 5. Now you take the derivative. You will give k5 1 by R square. Okay, 1 by R square. So k will come out 5 R4. So cancel out 5k R 5k R3. This is the divergence. And if we know this is equals to this one, rho equal to 5k epsilon naught this one. What we understand? Why? According to the question, we have to find the rho equal. We are getting 5 epsilon naught k R4. Oh, sorry, T. What is the total density? Total charge equal to rho dV. Now question is that in the first lecture I have given you the coordinate system. What is the volume in T coordinate system? You remember this dr, unit vector in spherical coordinate, dr r cap, r d theta, theta cap, plus r sin theta, d phi cap. This elemental length in spherical coordinate system. What is the volume? Volume is the product of T coefficient. Okay, T coefficient it will be. And in rectangular system, how we will write elemental length? Dx I cap, dy y cap, dz z cap. Okay, this volume equal to dx dy dz. Okay, coefficient of unit vector. Similar in spherical coordinate, elemental length in spherical coordinate, dr r cap, r d theta theta cap, r sin theta d phi phi cap. So you product this. What is the volume? Rho r square sin theta d theta d phi dr. This is the volume. Okay, do not write 4 by 3 pi r cube. This is the general formula. So it will be, put this value 5 epsilon naught come out. So 5 epsilon naught k come out. It will be R5 dr. This is this rho is does not depend on theta and phi. Okay, this will integral sin theta d theta 0 to twice pi, 0 to pi d theta. It will give 2. It will give twice pi. So it will be 4 pi. So 20 pi 5. Epsilon naught k R6 by 6. This is the answer. That is why you have to understand. And another example I am showing you. This question is also comes a search density. Question number 2. Rho r is the equal to a delta. A is constant. Delta r minus r. This question comes in the exam. Of a thin cell. Find the value of A. Find the value of A. How can you find out? So rho Q is the total charge. Q is integral rho dV. This formula you know. Rho equal to what? A delta r minus r dV. So dV you have to put this value. What is the formula of dV? dV now formula is this one. R square sin theta d theta d phi dr. So you put this value. A will come out. Integral delta r minus r square dr. This is independent. 0 to twice pi sin theta d theta. This is a 2 and you will get 4 pi a. This is r square, capital R. This delta function, you know that delta function. Delta function, you know this. Suppose fx delta x minus a dx equal to how much? Equal to f of a. This is the properties of delta function. Okay, then it will be 4 pi r square, and you can find out the value of a equal to q by 4 pi r square. This is the value of it. This question comes in that get exam. And this is what we need, this value. And another one or two example I am showing you. Another example. This question comes in a sphere of radius r. Example 2. A sphere of r equal to 2.2 m. Okay. And surface density rho is equal to 2 by under root of x square plus y square. Find the q value. Find the total charge. It is a spherical system. So you have, first of all, you have to solution. You have to consider x equal to r sin theta cos phi, y equal to r sin theta sin. You put this value here. So total charge equal to rho into dV. dV means r square sin theta d phi dr. This value you always remember. This is the general formula. And put this value here, you will get the answer. So upper limit, lower limit, you can get this question. This is why important. And next one or two question I am giving you that. Now you see question. Another question. This question only to understand what is the meaning of divergence and current. Example. Electric field is equal to R AR plus Z sin phi A phi plus Z AZ. Okay. Find E. Can you find the divergence? And then we have to calculate the surface density. Electric field in cylinder. How can you know this is cylinder? Because R phi Z. Unit vector is R phi Z. So this is a cylindrical system. So first of all, we have to calculate the divergence. So what is the formula? That is the general formula I am writing. H1, H2, H3. When I write H1, X1, H2, H3, F1. F1 means this component. This is F1. Now I am writing E, so you will write E. Okay? Or you can simply write R component. It is better. If you, once you understand, you will never confuse. So second term will be X2. When I write X2, H1, H3 is there. H1, H2 will be missing. This is E phi. Okay? third term will be D 1 2 E Z D X T. This is the general equation. So in cylinder, H1 equal to 1, H2 equal to R, H3 equal to 1. So it will be 1 by R. First term is 1 by R, D by dr. Okay, this is 1 2. It will give what? R ER. Okay, next term will be 1 by R is there. This is what? 1 T R F E 5 D 5. Okay, next term 1 by R is here. This is a common term. D 1 2 means R. This is 1. This is simply 1 and 2. H1 equal to 1, H2 equal to R, H3 equal to 1. 1 and T, this will not be 1, sorry. 1 T, this will be Z and R E Z. Okay. These are cancelled because this is Z. No need to write this part, only this. So what we understand is just now put to 1 by R, D by dr, put this value, ER component is R. So it will be R squared. Okay. Next term 1 by R, phi component is this one, 2 sin theta. 2 sin phi, phi d phi. Next term will be Z only. Z by dz. Okay, it will be how much? 2R will be 2R. R, it will R cancel 2. It will what? 2 will come out. 2 by R. Sin theta is a cos phi. And it will be 1. This is the answer. This is how you have to apply. Okay, it is very easy. Only need to understand what is the physical meaning of divergence, curl and gradient. So, last one, general formula of curl. But I am not going to derive this all the time. I am going to give you the general formula of curl. You just apply the parameter H1, H2, H3 according to the coordinate system. Okay. General formula of curl. F, I am writing F. This is curl means what? It will come in terms of matrix A1, H1, H2, H3, A2, H1, H3, A3, H1, H2. Del by del x1, del by del x2, del by del x3. Okay. Now H1 F1, H2 F2, H3 F3. Okay. This is the general formula for a curl. After that, this is the general formula. It's very easy to remember. A1, 1 is missing. H2, H3, 2, 1, 3, 3, 1, 2. This is simple, normal, what we do actually. Okay, after that, put this value F1, F2, F3. The component of vector, component F vector along 3 different directions according to the coordinate system. And after that, you have to apply. This formula is very essential when we have to know this formula. Because when we encounter a problem, this type. Okay. In exam, whatever magnetic field will be given, we have to calculate the current density. So in that case, you have to apply this formula. Suppose this is a spherical system or cylindrical system. Suppose consider cylinder having radius r and current density is J, magnetic field will be given, or current density you have to calculate, magnetic field is already given, then you have to calculate according to this formula. In order to use this formula, you have to know this formula according to the coordinate system. Okay? And I request you, all of you, to see my video from starting to ending. Okay? Then once you understand this basic thing, you can easily understand the David Griffith book. Once you understand the David Griffith book, your concept will be clear. You can understand any question, any type of question that comes in exam. I will solve the problem from the Gauss law application. This is the basic part of electrodynamics. Okay, and this is vector calculus is very, very essential in order to understand the physics. Must be essential. Okay. So I am not going to give you more because you will confuse. Otherwise, I will apply again. Give the hints. What type of why equation is like that. After that, I will give the general formula. We will discuss the problem and we will solve the problem. Okay, keep watching my video. I hope you will enjoy. And if you have any query, if you don't understand, you can send SMS or send message below the video. Okay, thank you.